In the second half of 4.5, we'll keep working with slope-intercept form, but really focus in on parallel lines. And the most important thing to know about parallel lines is that they're going to always have the same slope. We know that parallel means that there are two lines that will just never cross over each other. It would look like that. And that means they're going to be equally steep. And to be equally steep would mean that you'd have to have the same slope, because the slope tells us how steep the line is. So when we look at two equations like the 2 over here, I can tell ahead of time that they're parallel because they both have a slope of 2. The slope is m, and it's always the letter in front of the x. I'm going to graph these just as a reminder of what we did yesterday, and then we can see how it turns out that they're parallel. So in the first one, I'm going to start with the y-intercept. That's b, and it's the number that's not with the x, and I'll put that on the y-axis. And then for the slope, I need a rise over run, so when it's a whole number, I'm going to put a 1 underneath it. So I have a rise of 2 and a run of 1, and they're both positive, so I went up and to the right, and then that would be that first line. In the second line, the only thing that's different is that I'm starting on a different y-intercept, so I'll start down on the -3, but with the slope of a whole number positive 2, I'll put a 1 under it, and then I would do rise 2 and run 1, and get the same amount of steepness, which is going to make the lines parallel. We could probably just tell by looking which two lines are parallel, but I'm going to show with ordered pairs which two lines are parallel. So I'm just going to find the slopes by counting 1, 2, 3, 4, 5, 1, 2. So this first line has a slope of up 5 and 2 to the right. And then the second line is 1, 2, 3, 1. And so that's going to be up 3 over 1, rise over run. And then this third line, it starts in the middle of a square, but I can still count the squares. I can just go up 1, 2, 3, 1. So it's also up 3 and over 1. So it's these two lines that are parallel. And we probably could tell just from looking. Okay, in this example, all of these lines have a negative slope because they're all going downhill. And I'll just start counting squares. So I'm going to count down 1, 2, 3, 4, and then over 1, 2. So this one went down 4 over 2. And then I'll take a look at this one. It's going down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So down 6 and over 3. And those are the same because they both simplify to just be -2. And then this one, I can tell it's not going to be the same because it starts in the middle of a square, but it ends on the end. So it's going to be down 1, 2, 3, 4.5, and then it's over 2.5. So down 4.5 over 2.5. It's pretty close, but it's not equal to -2. So it would be these two lines that are parallel. Without looking at a graph, just looking at a pair of equations, if they're in slope-intercept form, y equals mx plus b, it's pretty easy to tell if they're parallel because I just need to look at the number in front of the x. And since they're both 4, yes, those lines are parallel. They might not always be written in exactly the right order, and so I do want to notice it's the number in front of the x, and it would include the negative, so these are not parallel. This line would be going uphill, this line would be going downhill. They'd be equally steep, but going in different directions. And in this equation, or in this pair of equations, there's the slope and there's the slope, and that would be a yes. And then we come to a pair of equations where they're not written in slope-intercept form, so I need to solve these equations for y. So the first thing I'm going to do is subtract 10x's from both sides. And then I'll divide everything by 2. Now I have the y by itself, and my slope is 7 over 2. Or sorry, that's the y-intercept. And then the slope would be -5x, because I'd be doing the -10 divided by 2. So this one has a slope of -5. We'll find out if this one also does. So I want to get y by itself. So the first thing I would do is subtract 5x's from both sides. It kind of seems like it's going to have a slope of -5, but it's really not. These would cancel out, but then I can't leave that as just a negative y. I have to make it a regular y. And when I divide everything by -1, the intercept turns into a -6, and the slope actually turns into a +5. So these are not parallel. Okay, and last ones to check. This one's in slope-intercept, so I know the slope is -0.6. And this one I'll have to solve for y. So I'm first going to subtract 3 x's from both sides. And then I'll divide everything by 5. 8 divided by 5 is 1.6. And -3 divided by 5 is -0.6. And since that's with the x, that's the slope, and that's a match. So yes, those are parallel.